Hey everybody, and welcome back to Algebra 2 Online. So the plan for today is to talk about something super important. It kind of pops up when you run into certain types of log equations. Basically what I'm going to show you is I'm going to show you a shortcut to deal with actually situations like this. So last time we saw some stuff like this, and we could just use inverse functions to basically solve this. So we would use like base 6 exponential right there, and it would cancel log base 6, and you just get x equals 6 cubed, right? But down here, if you do that, so you would, you could try the same thing, but, you can't do like 6 to the 2 and 6 to the log here, because you can only do something to once to each side in an equation, right? So that cancels still, that part's good. Then we get 6 to the 2 minus log base 6 of x minus 9. And so the only way we could proceed here, right, is basically using properties of exponents. And so we could do x equals 6 squared, and then we would, this is like the property, some base to the a plus b is just that base. I shouldn't use b twice. A plus c is that base to the a, and then that base to c, right? So if I just use that, then it's going to be 6 to the negative log base 6 x minus 9. And then I would get like a 36. The negative is just going to put it on the bottom. And so I would have 6 log base 6 x minus 9. And then, that could simplify more. Now I could do canceling here, right? And put 36 over x minus 9. And then I could multiply by x minus 9 on both sides to get x times x minus 9 equals 36. Now, that's a lot of manipulating with exponents and moving stuff around. And so it turns out that there's actually a way that we can do this basically much quicker. And it all just ties in really with properties of exponents, which is all we're going to use, all we used here, and all we would really need if we ever want to simplify logs, because they are exponents. So we can use exponential properties to do it. But basically, I'm going to show you a way to go from the original equation to here much quicker than doing all this every time, okay? So a lot of places call them log properties, but really they're exponent properties, which is why I kind of put them side by side here. We know, we just used this, right? That if you have, a to m plus n, it's a to the m times a to the n. And then if you subtract, that's division, right? Or if you have division, that's subtraction of the exponents. And if we do a power of a power, you multiply, right? So logs are just exponents, right? So these properties that I'm doing with the exponents should apply to these things. And so they do. So what we typically will do is actually we would take two things like this, and we would put it into one log. It simplifies it, right, if we go this way. So what I mean by that is we might have, it does have to be the same base. So these are all base 10 logs, right? But I could have something like natural log, maybe like a base e log, natural log of x, okay, plus natural log of x squared. And that property says I can combine them with multiplication. So that would equal natural log of x cubed. And this is typically the direction we go. We want to make, see two logs side by side and combine them into one log like this, okay? Same kind of thing here. If you ever see a subtraction it really relates to a division on the inside, just like subtraction, division, addition, multiplication, right? So again, we could do something like, we could have log base 2 of 7 minus log base 2 of x, and maybe we just want to combine that into one log, and if we did it that way, it would be log base 2 of 7 over x, okay? Whatever the negative one is what's going to go on the bottom. So negative minus log n there, n is on the bottom, okay? And then this one really actually is like the same thing as the first one, because if you have log base, whatever, let's just do base 10, and you have like m times m, right, inside, that is log of m squared, right? And if I use the first property though here, I can also think of this as log, I can split it into log base 10 of m plus log base 10 of m, which is 2 log base 10 of m's, right? And so you can kind of see like this 2 sort of passed in front of the, it's like we took the 2 and we just put it in front of the log now. So it was here and we're putting it here. And that's kind of what this property says, is like take whatever the exponent is and move it in front so you get an n there, okay? This can be really helpful for a bunch of different reasons, but one example is if you had log base, whatever, let's just do 3 or something, like 2 to the x, right? That seems like a complicated thing, but really you could just move the x in front, and now it's x times log base 3 of 2, right? And this log base 3 of 2 is just a number. So this is literally now just like a number times x, right? Which seems like something we would all understand a lot better than this thing, okay? So, and this really is another exponent property. It's really just the multiply one. We're just saying multiply. When you have a power in there, you have a power like this, you multiply them, and same thing here, you just multiply, okay? Basically the plan for the rest of this video is just go through examples where I show how to use these properties to help us. So this is actually the first example, and before I did it this way, where I use this property of exponents and could simplify it, right? But if we use log properties, I could just add that log on the right over to the, like basically I want 2 logs together if I'm going to use log properties, right? Now, if 2 are added together like this, I can just consider that as multiplication of the insides, like the m and the n, okay? So this is now really going to combine to log base 6. It does have to be the same base, but they are. And then x times x minus 9 now equals 2. And then now it's just like a problem from the last video. Now you can just use inverse operations and just kind of proceed like it was one from the last video. So that's kind of doing this first thing. So use properties of logs or basic just kind of algebra techniques to isolate a log. Now I've got a log isolated just by itself. And then I'll cancel it with inverse operations. So I'll just do 6 to both sides, right? And I will get x times x minus 9 equals 36. And you can see I've gotten to this point, which I got to in this problem, but I got to it with way more work, right? This is a much, much quicker way to get to this if you just utilize that first property right there. Now it's just a quadratic. The rest of this just says like solve resulting problem, but this is really important. Logs are not well-defined functions. They don't exist for all real numbers, so you have to check them. But the solving part here will be pretty quick. So we got x squared minus 9x equals 36. I'm going to move this over. And then, let's see, yeah, that can factor nice. So it's looking like x is 12 and negative 3, right? But then you got to check answers, okay? And so, you can really just go, and if the log is like negative, like I can see right here is what I'm saying. This negative 3, if you go and plug it in right there, I can already see it's not going to work, right? I can't take log base 6 of negative 3. That does not work. So this one for sure needs to be thrown out. The 12 we should actually plug in and see. So log base 6 of 12 over there. So here, if you do log base 6 of 12 minus 9, you get 3. And if you do 2 minus log base 6 of 3, it actually will equal log base 6 of 12. So so that one actually does work. That one's well defined and everything. So so that's kind of the plan for, this is about as hard as log equations get when you start to mix, multiple logs into the same question like this, like as different terms. And whenever that happens, I would just recommend you get them together on the same side so that you can use a log property to isolate it, to get it into one log, right? And then it's just inverse operations from there to the end. And don't forget to check answers. All right, so this one has 3 logs in it, and I can start by simplifying because I have subtraction between these two, right? So there was that property that said, I'll go back to it. So this property just says if you have subtraction between the logs, then you can do division like that. They do have to be the same log though. And these are base 10, so you can definitely do it. So, so we got log of x plus 12 over x, right? Now less than log of x plus 9, right? And then this one is kind of like our nice case with solving logs. You basically can just go ahead and just cancel the log because you have, the same one on both sides. So if you're taking log base 10 as something and it's less than log base 10 as something else, these inside things better just be equal. So x plus 12 over x is less than x plus 9. And then basically we're just going to get a quadratic inequality. So if I multiply by x, I'll get x squared plus 9x. Move everything to one side. Oops. 9 minus 1x is 8x, and then minus 12. All right, so for this quadratic inequality, still going to do the same thing where we have to graph it and look at the picture to kind of answer it from there, but we do need the roots, and the roots are kind of messy in this one. I would just do quadratic formula. The roots should be negative 8 plus or minus square root 112 over 2. And so that means if we go to our picture, right, there's basically, and I don't exactly know what decimals these are. I mean, I could figure them out, right? Just go to calculator, but I know that the smaller one is negative 8 minus square root 112 over 2. And the bigger one is negative 8 plus square root 112 over 2. I don't even know that they're symmetrical or anything. I just kind of drew them that way. But then, I've got a positive quadratic that's going through those roots. And same kind of thing as all these other quadratic inequalities. We want to know when is it greater than 0. And so that is this chunk and this chunk, right? So, all right, so the answer to this thing would then be, it's an OR, right? So it's going to be like x bigger than negative 8 plus square root of 112 over 2, or x is less than negative 8 minus square root of 112 over 2. And so I'm not going to circle it yet, right, because we got a log, and we have to do domains, right? So there's like 3 domain checks, because you got 3 logs. So this one I'll do in blue here. We need x plus 12 greater than 0, so x needs to be bigger than negative 12, right? And then, I don't know, I'll do this one in white. That's just a normal old x greater than 0. And then do that one in yellow or something. X plus 9 needs to be greater than 0, so x needs to be bigger than negative 9. And so you need to work for all of these different things, right? Like, you need to check this answer, I guess, against these things, right? So, one thing I'm seeing when I compare these two is you need x to be bigger than 0, right? Which really means we can throw out these two, right? Because, if you plug in like, I don't know, negative 8 works in there, right? Negative 8 is bigger than negative 9. But negative 8, if you plug it in here, like, it's going to be fine in there. And it's also going to be fine in there, right? But negative 8 in here is not going to work. So these ones don't work with that domain, so you have to throw these ones out. Then really it makes the whole checking process easier, because now you're just sort of checking this and this. And so you can also see that you need to check out the negative stuff, right? If you do negative 8 minus something, right, it's going to be more negative. That's a negative number for sure. This one, we really just need to know the decimal, because it could affect the answer. So, if you do it out, you'll see that this is approximately 1.29. And so 1.29, you basically need anything bigger than 1.29 is already bigger than 0, right? So any of the stuff in here will work for this whole thing, okay? So your final answer is x just needs to be bigger than 1.29, or that negative 8 plus square root of 112 over 2. But you just leave it this way, that's fine. But yeah, anything bigger than here is bigger than all of these, right? And so it's the only thing out of this solution inequality set that works in the problem. All right. So I think I got 2 more, and these last 2 are exponential equations instead of log, but we're going to still use log properties to solve them, okay? So what I'm going to do first is probably just going to get that fraction gone, and so I'm going to do it this way. If I was trying to solve this out, I might not like the fraction, so I might write that as e to the minus 4x. And so now we're in this weird situation, which we've never actually been in before, where we want to cancel off one of these exponentials, right? But we're not going to be able to cancel both in the same step. So it's going to take a little bit of work. So what I'm going to do is I'm just going to take natural log of both sides. And I'm taking that because if I take natural log of this, right, then natural log and e will cancel because they're inverses. But over here, you're not going to be able to cancel much. Let's just copy that down. So you're going to have natural log of 10 to the 3x minus 7. Right? And then over here, you do cancel things. You just get minus 4x. Right? Now, you're going to be able to see why this is a log property problem. So we have this property. It's the third one, which maybe it's not surprising that the third example involves the third property. But it says that if you have a power like that, you can move the power in front, right? So I can simplify this that way. And so if I do that here, I'm going to take my power, right? Take this power, and I'm just going to move it in front. That's all I'm going to do. So I'm going to have 3x minus 7, and then all of that now times natural log of 10, still equaling this, right? And if you look at this, we have actually just turned the problem into like an Algebra 1 linear equation, right? Because we can just, this is a number, we can just distribute that number over, okay? And basically just combine like terms and solve for x and we'll be done. It's not even like a quadratic or anything like that. You know, x is to the first power. So let's just go and do all that. So we've got 3 times natural log of 10 times x in the first distribution. And then we got minus 7 times the natural log of 10 in the second. And then I think I'm going to move the minus 4x to the right. So I'm going to have 3 natural log of 10x plus 4x. And then I'm also going to add the 7 natural log of 10 over here. All right. And then I can just factor an x out of this. All right. So I have 3 natural log of 10 plus 4 all times x equals 7 natural log of 10. And then you just literally one last step, right? We want to divide out by 3 natural log of 10 plus 4, because then it'll cancel there and you'll have x by itself. And so, let's just go up here. So final answer would just be 7 natural log of 10 over 3 natural log of 10 plus 4. And there is a natural log button on your calculator and everything, but it's the same way that, you know, like I never want you doing like the square root of 21 or something. It's not nice. You would just leave square root of 21. You would just leave this answer. This is the best way to actually write the answer to that problem. You wouldn't want to bring in decimals. It's actually already like a pretty nice form. So yeah, I know it looks a little weird, but it's just 7 times the natural log of 10, all divided by 3 times the natural log of 10 plus 4, okay? And you don't need to check answers because it's exponential, so whatever you get should work just fine, okay? So I wanted to do another one of those, probably looks a little scarier. It's really not too much crazier than the last one. I'm just going to actually have a picture too on this one that I can kind of show you the solution to. But so if I was solving this exponential equation, I would just start by simplifying lots of stuff here. So you got e to the 2x all over e times e, which is just e cubed, right? And then all this stuff over here is powers of 7. 49 is 7 squared, 343 is 7 cubed. So you really have 7, 3 7s there, 2 more, so it's 5, plus another one is 6. So you have 7 to the 6th power, and then you still got this minus x minus 5. Actually, I'm going to do that a little different. I just don't want to do too much. So let's do 49 is 7 squared, okay? And times another 7 is 7 cubed. So we'll just do it this way. And then 343 is 7 cubed also. All right, I think this will be more clear. And then properties of exponents here, you can subtract those, right? So you have e to the 2x minus 3 is less than 7 cubed. And then this property of exponents is that we multiply these things. So we would have 7 to the minus 3x minus 15. And then, just copy that over. Here we add exponents, right? So we do 7 to the minus 3x, and then we just do, you know, minus 15 plus 3 is minus 12. All right, so that's just all the simplifying. And then I'm just going to take, last time I did it where I canceled e, but I think this time I'll just cancel the 7 for no good reason. So I'm going to just take log base 7 of both sides. Okay, so I'm just literally doing that so that I can cancel it here, right? So that means I'll have log base 7 of e to the 2x minus 3 now is less than minus 3x minus 12. And now, finally, log properties. We got to move that in front, okay? So we're going to have 2x minus 3 times log base 7 of e, and all that's got to be less than this. And then at this point now we have a Algebra 1 inequality. This is, just like the last problem, we can distribute that. Then we'll combine like terms and we'll be good. So I'm going to do just split that up a little bit. So 2 times log base 7 of e x, and then I'll have minus 3 log base 7 of e is less than minus 3x minus 12. And then I think I'll just add all the x stuff to the left and the numbers to the right. So I have 2 log base 7e x plus 3x is less than minus 12 plus 3 log base 7e. Factor out the x. And then at this point, we've got this thing, right, that we can just divide over to the other side. And our final answer would be x is less than minus 12 plus 3 log base 7e all over 2 log base 7e plus 3. So I'm sure this stuff is very hard to read, but what I want you to see, I'll make this a little bit more, a little bit bigger here. So there's a point here, and that point is labeled negative 2.597, 0. And the black curve, which looks like this, is the left side, and the blue one is the right side, okay? And the intersection of those two exponential curves is that weird negative number. If you go and you plug this in, this is the best form for the answer, but this is actually negative 2.597, blah, blah, blah. It keeps going forever and ever and ever. And so what it's saying is the black curve is below the blue curve, less than that intersection point, but then as soon as you pass over the intersection point, right now, all of a sudden it'll become above it. So that is actually the weird correct answer. And that is actually the best way to write the answer. I don't want you using your calculators to basically go and get the annoying decimals. It's not going to help you. Also, if you go and use these things in the real world, you can get rounding errors if you start getting decimals too early. So you want to only round final answers, and it's good to get you in the habit of not rounding too early right now. So those are all some kind of harder, definitely problems related to logs and exponentials, and all those use log properties somewhere. So hopefully you found it helpful.